In this video, we're going to continue our exploration of parabolas. Today, we're specifically going to look at the axis of symmetry and also where a parabola is increasing and decreasing. We're going to look at this graphically and also from equations. So the first part is the axis of symmetry. And the axis of symmetry is a vertical line that will divide a parabola into two equal halves. So whatever's on the left or the right of this axis of symmetry. And so this is this vertical line here, 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 and so on. Anything that's on the left and the right will be exactly the same, though it's basically a reflection from one side over to the other. What's great about the axis of symmetry is it does go directly through the vertex. Now again, we're talking about a vertical line, so our equation of a vertical line has always got to be x equals. So x equals 0, x equals -2, and so on. So really what we're trying to figure out is where's the quote-unquote center of this parabola. So from a graph, it's fairly easy to figure out where that axis of symmetry is. Essentially, all we're going to do is look at where that vertex is. So let's zoom in a little bit on, let's say, this graph right here. And what we want to do is figure out where is the vertex. And then once we know where the vertex is, we want to figure out the equation of the axis of symmetry. So because this graph is concave down, we know that the vertex is going to be at the high point, which is right here at 2, 3. The axis of symmetry is the vertical line that goes right through that vertex. So again, a vertical line is an x equals. We know that the x-coordinate of the vertex is 2. So our axis of symmetry is x equals 2. If we looked at one that was concave up, so let's say this guy right here, same idea. We're looking for the coordinate of the vertex. This one opens up, so our vertex is down here. And then so our x-coordinate, this is the point 0, -1. Our x-coordinate of the vertex is just 0. So we have a vertical line that goes through the vertex, and that's our axis of symmetry. X equals 0. So again, from a graph, not so bad. From an equation, it's going to get a little bit more challenging. So when looking at an equation, the important part that we're looking for here, the key piece of information when finding the axis of symmetry is what is the vertex? Now, as a reminder, in previous videos, we did take a look at picking the vertex out from the equation. But essentially what we're going to do is we're going to take the opposite of whatever's with the x here. So it's what's being subtracted from x. So that would be a -3. So our x-coordinate is -3. And their y-coordinate is whatever number's here at the very end, whichever's being added or subtracted to that quantity. So that's -4. The axis of symmetry is the vertical line that goes straight through the vertex, straight through the x-coordinate, which is -3. So our axis of symmetry is x equals -3. On a question like this one, we have 2x or -2x squared plus 3. Again, it doesn't matter if it opens up or down. The axis of symmetry is always going to be a vertical line through the vertex. The trick is going to be finding our vertex. So there's nothing in that quantity, nothing's being subtracted from x. So our x-coordinate must be 0, and our y-coordinate is just that 3 right there. Again, our axis of symmetry is the vertical line through the x-coordinate, so x equals 0. So that's how we're going to find axis of symmetry. The other part of what we're going to look at is where a function is increasing or decreasing. And we're going to start doing that by taking a look at a graph. So what we want to do is figure out this graph, just kind of describe what's going on here. So some key features, I know that this graph is opening down. I do know that my vertex is right here. And again, that's the ordered pair 2, 3. When I'm talking about where the graph is increasing or decreasing, I want an interval. I want x values. I want to know where is it going to increase or decrease. So just looking at kind of the shape, I'm going to trace this graph a little bit with my stylus here. And as I'm moving, this graph is increasing in value. So it's going up. And it seems like it stops right there once we get to that high point. And then it's going to fall. So that's a decrease. So we have an increase, stop, decrease. So as an interval, the increase starts actually way off the screen, someplace we can't even see, which goes all the way to negative infinity. So this graph is going to increase from negative infinity for the x until we hit the vertex, which happens to be at 2. So our interval of increasing is going to be from negative infinity to 2. Again, once we've hit that vertex, it temporarily stops for a second. It doesn't either increase or decrease at that vertex. Immediately after that vertex, though, we are going to fall. So we have a decreasing function. So it's going to decrease from that value of 2 until infinity. It's going to keep on decreasing forever. It never comes back up. So from there, we can also look at graphs that are concave up. Again, the same process is going to follow. We're going to look at what's happening from the left and from the right. So from the left, we have a decreasing function until we hit here, and that vertex is at 4, 2. So there's our vertex point right there. And then after that vertex, the graph is going to increase. So the interval first, again, I'm decreasing from negative infinity until I hit my vertex, which is at x equals 4. And then after 4, the graph increases, so my interval is from 4 to infinity. Now that's how we're going to tell from a graph. Equations are a little bit trickier, but what we can do is kind of draw a little rough sketch of what the graph's supposed to look like. So let's say, for instance, we had this graph here, number 3, why not? In order to get a rough sketch of the graph, I need 2 key pieces of information. I need to know where's the vertex, and I also need to know does the graph open up or down. So my vertex is going to be at 4, 6. I'll take the opposite of the x, so x minus 4, so 4, and then the y-coordinate is 6. Then I want to figure out if the graph opens up or down. I've got a number in front of here. It's not written, but there's actually a 1 in front of there. So that's a positive value. So that tells me my graph is going to open up. So I'm just going to do a real rough sketch of the graph. So 4, 6, I don't know, probably somewhere around here. Again, not perfect, doesn't need to be. I'm going to draw a sketch of the graph opening up. And then from there I can figure out my pieces of information. So the axis of symmetry, again, is just the x-coordinate of the vertex as a vertical line x equals. So x equals 4. And my graph, as I'm moving left to right, this graph is going to decrease until I get to my vertex, which is right here. And then it's going to increase. So I'm decreasing from negative infinity to 4 and increasing from 4 to infinity. And we can do this if the graph's opening down as well. So let's say we grabbed one like number 1. The vertex of this one would be at negative 3, negative 4. And because I've got a negative value, that's going to open down. So I draw a little sketch. All right, negative 3, negative 4, right over there. And opens down. Okay, so I've got my vertex at negative 3, negative 4. There's my point. Axis of symmetry is the vertical line that goes through the x-coordinate. And this graph will increase, followed by a decrease. So the increasing is from negative infinity to negative 3. And decreasing is from negative 3 to infinity. All right, so again, I could be wrong, but I think it's so much easier if we have a little sketch of the graph so we can figure out the increasing and decreasing intervals. Again, the axis of symmetry is just that vertical line that goes through the x-coordinate of the vertex.